Hi everyone. In this video, I will explain the difference between car batteries and solar batteries. A car battery is a type of rechargeable battery that is specifically designed for automotive applications. It is primarily responsible for providing electrical power to start the engine and supply electricity to various electrical systems in the vehicle, such as lights, radios, and other accessories. Car batteries are typically lead-acid batteries, which consist of lead plates immersed in an electrolyte solution of sulfuric acid. Key features of a car battery. Voltage. Car batteries usually operate at a nominal voltage of 12 volts, although there are variations. Capacity. Car batteries are rated in ampere-hours or reserve capacity, which indicates their ability to deliver a specific amount of current over a specific period. Starting power. Car batteries are designed to deliver a high burst of power to start the vehicle's engine. Rechargeable. Car batteries can be recharged by the vehicle's alternator while the engine is running. Limited energy storage. Car batteries are not intended for long-term energy storage and are primarily used for short bursts of high current applications. Solar battery. A solar battery, also known as a solar energy storage battery or solar panel battery, is designed to store electrical energy generated by solar panels. Solar panels convert sunlight into electricity, and a solar battery allows the excess energy to be stored for later use when sunlight is not available, such as during the night or during cloudy weather. Solar batteries are commonly used in off-grid solar systems or as backup power sources in grid-tied systems. Key features of a solar battery. Energy storage. Solar batteries are designed to store electrical energy for later use, allowing for a more consistent and reliable power supply. Deep cycle. Solar batteries are usually deep cycle batteries, meaning they can be discharged and recharged repeatedly without significant degradation. Capacity. Solar batteries come in various capacities and are rated in kilowatt-hours or ampere-hours, indicating the amount of energy they can store. Voltage. Solar batteries can operate at different voltages, depending on the system's requirements. Efficient energy use. Solar batteries allow homeowners or businesses to make the most of the solar energy they generate by using it during non-daylight hours. Differences between car batteries and solar batteries. Purpose. Car batteries are primarily used to start the vehicle's engine and power its electrical systems, while solar batteries are used to store excess energy generated by solar panels for later use. Energy storage. Car batteries have limited energy storage capacity and are optimized for short bursts of high current applications, while solar batteries are designed for long-term energy storage and can store larger amounts of energy. Rechargeability. Car batteries are recharged by the vehicle's alternator while the engine is running, whereas solar batteries are charged by solar panels that convert sunlight into electricity. Deep cycle capability. Solar batteries are typically deep cycle batteries, meaning they can be discharged and recharged repeatedly without significant degradation, while car batteries are not designed for deep cycling and may experience reduced performance or lifespan if deeply discharged. Voltage. Car batteries usually operate at a nominal voltage of 12 volts, whereas the voltage of solar batteries can vary depending on the system's requirements. Application. Car batteries are used exclusively in automotive applications, while solar batteries are used in off-grid solar systems or as backup power sources in grid-tied systems. Design and construction. Car batteries are typically designed to be compact, lightweight, and able to withstand vibrations and shocks commonly experienced in vehicles. They are often sealed and maintenance-free. In contrast, solar batteries are generally larger in size and are designed for stationary applications. They may require additional ventilation and maintenance, such as regular checking of electrolyte levels or cleaning of terminals. Environmental considerations. Car batteries contain lead and sulfuric acid, making them potentially hazardous to the environment if not handled or disposed of properly. Due to the risk of leakage, car batteries should be recycled at designated recycling centers. Solar batteries, depending on their chemistry, such as lead acid or lithium-ion, also require appropriate recycling or disposal methods, but their use in stationary systems allows for easier handling and containment. Cost. Car batteries are relatively affordable compared to solar batteries, which tend to have a higher initial cost due to their larger capacity and deeper cycling capabilities. However, the cost of solar batteries has been decreasing in recent years as renewable energy technologies become more widespread. Integration with power systems. Car batteries are integrated into the vehicle's electrical system and are typically not used to feed power back into the grid. Solar batteries, on the other hand, can be connected to off-grid solar systems to provide reliable power or can be used in grid-tied systems with net metering, allowing excess energy to be fed back into the electrical grid. Lifespan. Car batteries generally have a lifespan of around 3 to 5 years, depending on usage and maintenance. In contrast, solar batteries are designed for longer lifespans, often ranging from 5 to 15 years or more, depending on the battery chemistry and usage patterns. It's important to note that there are different types of solar batteries available, such as lead-acid, lithium-ion, and flow batteries, each with its own characteristics and advantages. The specific type of solar battery chosen depends on factors such as system requirements, energy storage capacity needed, cost considerations, and expected lifespan.